Hi everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. So today I want to discuss about non-exact differential equations. So already we know what is the non-exact differential equations, what are methods are there to solve the non-differential equations, and what are the methods are there, and method 1, method 2, method 3 and method 4 are already discussed in previous videos. Today I am going to discuss about method 5 for the solving of non-exact differential equations. First of all, what is the non-exact differential equation? Already we know, just I want to recall you. So here the differential equation of the form m of x comma y into dx plus n of x comma y into dy equal to 0. Not an exact differential equation. How we can say that this is not an exact differential equation means, so if we know the definition of the exact differential equation, then automatically you can tell about the not exact differential equation. So what is the definition of the exact differential equation? If dou m by dou y is equal to dou n by dou x, then we can say that the given equation is exact differential equation. So when we can say that this is not an exact differential equation, so dou m by dou y is not equal to dou n by dou x, then we can say that the equation is not an exact differential equation. So how to solve this non-exact differential equation? We are going to see now. So here we need to convert given not an exact differential equation into exact differential equation. After then, what is the procedure we are following to solve the exact differential equation? Same procedure we can follow in the remaining part. So what is the meaning of this here? How we can convert non-exact differential equation into exact differential equation? So by seeing this using integrating factors. So integrating factors are here different according to the given equation. So we can solve this non-differential equation by using the integrating factors. That means what is the suitable integrating factor? We can multiply with the given equation, then not exact differential equation convert into exact differential equation. So what are the integrating factors? So here we are having different methods, method 1, method 2, 3, 4, 5. So in the first one, grouping the terms. Here in the first method we are grouping the terms to convert the not exact differential equation into not exact differential equation into exact differential equation. In the second method, we are doing 1 by mx plus ny is the integrating factor. Then here one condition is there, this should be homogeneous equation. In the third method, 1 by mx minus ny is the integrating factor. Here equation should be in the form y into f of x comma y into dx plus x into g of x comma y into dy equal to 0. So here this is the third method. Next, coming to fourth method, we are having dou m by dou y minus dou n by dou x by n. This should be equal to f of x. That means here continuous single variable function will be there. Here we will get f of x value, means here only x terms. So this is the method 4. These all methods are already we discussed in the previous videos. Please go through once to get the better clarity about these methods. So now if the given equation is not belongs to method 1, method 2, method 3 and method 4, we are going to follow the method 5. What is the method 5? How to calculate and how to solve the non-differential equation by using the method 5, we are going to see now. See the method 5 here. For the equation m dx plus n dy equal to 0, here if dou n by dou x minus dou m by dou y by m value is equal to g of y, this should be continuous single variable function. Dou n by dou x minus dou m by dou y by m is equal to g of y. So here this is the function of y alone. That means only we will get here y terms, only y terms. So then integrating factor is e power integral g of y dy. E power integral g of y dy is the integrating factor of m dx plus n dy equal to 0. M dx plus n dy equal to 0. So here in the method 5, what we need to calculate? We need to calculate the value of dou n by dou x minus dou m by dou y by m. This value should be equal to g of y. G of y means we need to get only y terms. So this is the value we are going to find in the given equation. So now we can get the clarity about this method 5, how to solve the given equation by using this example. See the example problem. Solve. The given equation is 3x square y power 4 plus 2xy into dx plus 2x cube y cube minus x square into dy equal to 0. So here this is m dx plus n dy equal to 0 form. So given equation is in the form of m dx plus n dy. So what is the m value? M value is 3x square y power 4 plus 2xy. This is the m value. And what is the n value? N value is 2x cube y cube minus x square. So now we are going to calculate dou m by dou y value and dou n by dou x value. Why we need to calculate these two values? These two values are equal. Then we can say that the exact differential equation, we can follow the procedure for the exact differential equation. If it is not equal to, then only we are going for the methods. So first of all, we have to check about these two values. So dou m by dou y. So here we are doing the partial differentiation of m with respect to y. So when you are doing with respect to y, so x is the constant, 3 also already constant, x square is constant. So derivative of y power 4. So that is 4y cube. Derivative of y power 4 is 4y cube. Plus here 2 and x both are constants. So y derivative is 1. So finally dou m by dou y value is 3 4s are 12. So 12x square y cube plus 2x. This is the value of dou m by dou y. Now we are going to calculate dou n by dou x. So this is the partial differentiation of n with respect to x. So when you are doing with respect to x, y is treated as constant. So 2 is already constant. Y cube also constant. Now we are doing the differentiation of x cube. X cube differentiation is 3x square minus x square differentiation is 2x. So finally this value is 2 3s are 6. So x square y cube minus 2x. This is the value of dou n by dou x. Here dou m by dou y value is 12x square y cube plus 2x. Dou n by dou x value is 6x square y cube minus 2x. So here dou m by dou y is not equal to dou n by dou x. So that means this is non-exact differential equation. This is non-exact differential equation. So after deciding this value, we have to check about this equation belongs to which method. So we are having the 5 methods. First method is grouping the terms. So here when you are seeing the equation, if there is a possibility to grouping the terms, then we can follow the method 1 for. But here when you are seeing here the equation, there is no possibility to grouping the terms. So first method is not possible. Next, second method, you should have the homogeneous equation. And mx plus ny not equal to 0. These two conditions should be satisfied. So here this equation is not homogeneous. So second method also not possible. Next, third one. Here the given equation should be in the form y into f of x comma y into dx plus x into g of x comma y into dy equal to 0. So this equation is not in that form. So third method also not possible. And here fourth method, we are going to calculate dou m by dou y minus dou n by dou x by n. This is should be f of x. This is should be f of x. That means we can check this value, and if it is we are equal to f of x, then we can follow the method 4. Otherwise, we have to follow the method 5. What is the method 5? Dou n by dou x minus dou m by dou y by m value should be equal to g of y. That means here we need to get only y terms. That value we are going to see now. First, I will calculate from method 5 value. If we are getting only y terms, we are going to follow the fifth one. So, fifth method. So, if you are getting only x terms here, then we can follow the method 4. Now, you can see here dou n by dou x minus dou m by dou y. Here is equal to dou n by dou x value. What is the dou n by dou x value? 6x square y cube minus 2x. 6x square y cube minus 2x minus of dou m by dou y value. 12x square y cube plus 2x. 12x square y cube plus 2x. Now we are simplifying this. 6x square y cube minus 12x square y cube minus 2x plus 2x. This 2 will be cancelled. Finally, we are getting here minus 6x square y cube and divided by m value. Divided by m value. So, what is the m value? Minus 6x square y cube by. So, m value is 3x square y power 4 plus 2xy. 3x square y power 4 plus 2xy. So, here when you take the common here, minus 6x square y cube, here x, y, we are taking the common here. So, 3x and here will be the value of 3xy, and already x is there, y is there, so 3xy cube plus xy. So, and here we can take one more x also common, so x square. So here this is 2xy. So already x and y are common, we can write the 2 value. So when you are simplifying this equation, we are getting the value here, that is minus 2 by y. So this value is, so when you are simplifying this value, we are getting here minus 2 by y. So only we are getting y terms. That means this value is equal to g of y. So here we are going to use the method 5. What is the method here? Method 5 we are going to use. So here why we are going to use method 5? We are getting here only y term, that is equal to g of y. This value is equal to g of y, means we are following the method 5. So after calculating this value, we are going to calculate integrating factor, that is e power integral g of y dy. So what is the g of y value? E power integral minus 2 by y dy. So here minus 2 is the constant, integral 1 by y dy. So what is the integral 1 by y? That is log y. So e power minus 2 log y. So equal to e power log y power minus 2. That means this value is 1 by y square. So here we got integrating factor value is 1 by y square. So we are going to multiply the equation 1 with this integrating factor. Now, what is the given equation? Given equation is 3x square y power 4 plus 2xy by y. 1 by y square. 1 by y square is the integrating factor into dx plus, and n value. What is the n value? 2 into x cube y cube minus x square, and here multiplying with integrating vector, that is 1 by y square into dy equal to 0. So when you are simplifying this equation, this is 3x square y power 4 by y square. So y square will be cancelled. We are getting here 3x square y square plus 2xy by y square. So 1 y will be cancelled. So 2x by y. This is about the m term. Now we are going to simplify the n term here. 2x cube y cube by y square. So y square will be cancelled. Here 2x cube y. Next minus x square by y square. So x square by y square into dy equal to 0. Now I got new m value, that is we are writing as m1. So m1 dx plus n1 dy equal to 0. So now we got the equation form m1 dx plus n1 dy equal to 0. So after getting the new m1 and new n1, we are going to calculate same dou m1 by dou y value, dou n1 by dou x value is equal to dou n1 by dou x. So then we can solve the given differential equation. So that's why now we are going to calculate dou m1 by dou y here. What is the m1 value? m1 value is 3x square y square, 3x square y square plus 2x by y. 3x square y square plus 2x by y. So here n1 value is, what is the n1 value? Here 2x cube y, 2x cube y minus x square by y square, x square by y square. So we are going to check about the exactness here. So that is dou m1 by dou y. So with respect to y we are doing 3x square is constant. So y square derivative is 2y plus 2x is constant. 1 by y derivative is minus 1 by y square. So finally this is 6x square y minus 2x by y square. And here dou n1 by dou x. With respect to x we are doing 2y is the constant, x cube derivative is x square minus 1 by y square is the constant, derivative of x square is 2x. So finally this value is 2 3s are 6 x square y minus 2x by y square. So dou m1 by dou y is not equal to dou n1 by dou x. Sorry, here both are equal. We got the same values. Dou m1 by dou y is equal to dou n1 by dou x. That means this is the exact differential equation. So we converted the given non-exact differential equation into exact differential equation by using the integrating factor. So now we can follow the procedure what we done for the exact differential equation. So if it is exact, what we have to do? We have to find the general solution. So what is the general solution? Integral m dx plus integral n dy equal to c. So what is the new differential equation, exact differential equation? We are following that. That's why we are taking integral m1 dx plus integral n1 dy equal to c. When you are taking the m1 value, you should remember y is stated as constant. When you are casting the n1 value, we will take only y terms free from the x. So we should not take x terms, we will going to take only y terms here. So what is the first term here? 3x square y square plus 2x by y into dx plus here integral n1 value. When you are observing the n1 value, there is no separate y term and there is no possibility. There is no possibility to separate the y term also. That's why we are taking 0. So here integral 3x square y square plus 2x by y into dx plus integral 0 into dy equal to c. So 3 is the constant, y square also constant. So integral x square dx plus 2 by y also constant, integral x dx plus 0 equal to c. So 3y square into integral x square dx is x cube by 3 plus 2 by y is the constant, integral x dx is x square by 2 equal to c. So here 2 will be cancelled, here 3 will be cancelled, x cube y square plus x square by y equal to c. This is our general solution for the given non-exact differential equation. So this is the general solution. So this is the way to solve the given problem by using the method 5. So I am moving to one more example. We can see here. Solve xy cube plus y into dx plus 2 into x square y square plus x plus y power 4 into dy equal to 0. So first of all, in the solution, what we are writing? Writing the given equation. So given equation is xy cube plus y into dx plus 2 into x square y square plus x plus y power 4 into dy equal to 0. So now this is in the form of mdx plus ndy equal to 0. So what is the m value? M value is equal to xy cube. Xy cube plus y. Xy cube plus y. And what is the n value? N value is 2 into x square y square plus x plus y power 4. So now we are going to check about dou m by dou y and dou n by dou x value. What is the dou m by dou y value? Dou m by dou y value is here. When you are doing with respect to y, x is the constant. So derivative of y cube is 3y square plus derivative of y is 1. So finally this value is 3xy square plus 1. And here dou n by dou x. What is the dou n by dou x? So 2 into here. When you are doing with respect to x, y is constant. So 2y square is constant. Derivative of x square is 2x. Plus here we are having 2 and x derivative is 1. Plus here having 2 and y also constant and x here this will be 0. So finally we are getting here 4xy square plus 2. So here dou m by dou y is not equal to dou n by dou x. That means this is not exact differential equation. This is non-exact differential equation. If it is non-exact differential equation, we have to check about method 1, 2, 3, 4 and 5. So if it is good, if there is a possibility to grouping the terms, then we can follow the method 1, but there is no possibility to group the terms. So first method is not possible. Second method, we should have the homogeneous equation. This is also not possible. And second one, we should have the y into f of x plus x into g of, this is x, f of x into x plus x into g of x comma y into dy equal to 0 form. This is also not possible. Fourth one, we have to check about dou m by dou y minus dou n by dou x by n value, and here dou n by dou x minus dou m by dou y by m value. This should be equal to g of y. This should be equal to f of x. So we are going to check about these two conditions. So here, so after calculating dou m by dou y, so here dou n by dou x minus dou m by dou y I am calculating now. So what is the dou n by dou x value? 4xy square plus 2. 4xy square plus 2. Here minus 3xy square minus 1. So by m. By m. What is the m value? xy cube plus xy cube plus y. So here 4xy square minus 3xy square is xy square plus 2 minus 1 is plus 1 by here xy cube plus y. So here when you take the common here y common, so xy square plus 1, in the denominator I am taking y common, so xy square plus 1. So these two terms will be cancelled. I am getting here 1 by y. So this is g of y. So I am getting here method 5. That means we can apply the method 5. So dou n by dou x minus dou m by dou y by m value we got 1 by y. So now we can calculate the integrating factor. So integrating factor is e power integral g of y dy. So g of y value is 1 by y. So integral 1 by y dy. So e power log y. So you can write this one as a y log e base e. So finally this value is y. So integrating factor value is y. Now we are going to multiply the given equation with integrating factor. So xy cube plus y into y dx plus 2 into x square y square plus x plus y power 4 into y dy is equal to 0. So here xy power 4 plus y square into dx plus 2 x square y cube plus 2xy plus 2y power 5 into dy equal to 0. Now this is equation in the form of m1 dx plus n1 dy equal to 0. So here we can check about dou m1 by dou y value and dou n1 by dou x value. We are going to get these two values are equal. So that means this is exact differential equation. This is exact differential equation. So if it is exact differential equation, what is the procedure we are following? We are following for the general solution. So what is the general solution? You can observe here. Integral m1 dx plus integral n1 dy equal to c. So what is the m1 value is x y power 4 plus y square into dx. Here when you are doing the integration part for the m1, we'll treat y as a constant plus integral. What is the n1 value? So n1 value is 2 into x square y cube plus xy plus y power 5. So here we should take only y terms. Here xy is there. Here also xy is there. In the last term y term is there. So we can take 2 into y power 5. So 2 into y power 5 into dy equal to c. That's why we taken here 2 into y power 5 because they only given in the formula. So we should take only y terms. So integral, here y power 4 is the constant. So integral x dx plus y square is the constant, integral dx plus 2 is the constant, integral y power 5 dy equal to c. So finally this is y power 4, integral x dx is x square by 2 plus y square into the integral dx is x plus 2 into integral y power 5 is y power 6 by 6 equal to c. So when you are simplifying this equation, x square y power 4 plus 2xy square plus 2y power 6 by 3 equal to c. This is our final general solution of the given equation. This is the way to solve the given equation by using the method 5. We are moving to one more example here. Observe given. What is the given equation? Given equation is y power 4 plus 2y into dx plus xy cube plus 2y power 4 minus 4x into dy is equal to 0. So this is in the form of mdx plus ndy equal to 0. What is the m value here? M value is y power 4 plus 2y. What is the n value? N value is xy cube plus 2y power 4 minus 4x. So here we are going to check about exactness. So dou m by dou y value. So dou m by dou y is here y power 4 is 4y cube plus 2 into y derivative is 1. So finally this value is 4y cube plus 2. Now I am going to calculate dou n by dou x. What is the dou n by dou x here? So y cube is a constant, x derivative is 1. Plus 2 and y power 4 both are constant, that is 0. Minus 4 into x derivative is 1. So finally this is y cube minus 4. So dou m by dou y is not equal to dou n by dou x. So this is a not exact differential equation. This is not exact differential equation. So what we are going to calculate now based on the method 5. So dou n by dou x minus dou m by dou y. So this value I am going to calculate now. So dou n by dou x value is y cube minus 4 minus of dou m by dou y value is minus 4y cube minus 2 by m value. What is the by m value? So m value is here y power 4 plus 2y. So here this is y cube minus 4y cube is minus 3y cube. So minus 4 minus 2 is minus 6 by y power 4 plus 2y. So here I am taking the common minus 3. So y cube plus 2. Here I am taking the common y. Here I got y cube plus 2. These two will be cancelled. Finally I got this value is minus 3 by y. So that means this is equal to, this value is dou n by dou x minus dou m by dou y by m value I got minus 3 by y. This is equal to g of y. This is equal to g of y. We can observe this value here. So dou n by dou x minus dou m by dou y value we got minus 3 by y, minus 3 by y. That is equal to g of y. So now we can calculate the integrating factor. What is the integrating factor here? E power integral g of y dy. So e power integral minus 3 by y dy. So here minus 3 is the constant. Integral 1 by y dy. So integral 1 by y dy is log y. So here log y power minus 3. That means I got here 1 by y cube. This is the integrating factor. So now I am going to multiply the given equation with the integrating factor. So y power 4 plus 2y into 1 by y cube into dx plus xy cube plus 2y power 4 minus 4x into 1 by y cube into dy equal to 0. Now this is equation in the form of m1 dx plus n1 dy equal to 0. Now we have to check about the exactness. We should get here dou m1 by dou y is equal to dou n1 by dou x. So this is the exact differential equation. Now we can follow for the general solution. So now we can see what is the general solution is here. Integral m1 dx plus integral n1 dy equal to c. What is the m1 value? M1 value is y power 4 plus 2y by y cube. And what is the n1 value? N1 value is xy cube plus 2y power 4 minus 4x by y cube. Minus 4x by y cube. So now here when you are doing integration for the m1, we will take y as a constant, and when you are doing with respect to integration of n1 with respect to y, here we will take only y terms. So if there is a possibility to take the only y terms or not, we have to check here. So here x cube by xy cube by y cube minus 2y power 4 by y cube minus 4x by y cube. This is the n1 value. So in the first term we are having xy. In the last term also we are having xy. So that means we can take only second term. So y cube will be cancelled. Finally we can take this value as minus 2. And here we are going to take this value. So integral y plus 2 by y square into dx plus integral minus 2y into dy equal to c. So when you are taking m1 value, y is treated as constant, right? So y integral dx plus 2 by y square integral dx minus integral 2y dy equal to c. So here y into x plus here 2 by y square into x minus 2 into y square by 2. 2 will be cancelled, and here we can take the x common. So y plus 2 by y square into x minus y square equal to c. So this is our general solution. This is our general solution. So this is the way to solve the given non-exact differential equation by using the method. I hope we get the better clarity about this method 5 for the non-exact differential equation. If you want more examples, you can follow these textbooks and you can refer the Google links also. So here Higher Engineering Mathematics written by B.S. Gravel, and one more textbook also is there, a textbook of Engineering Mathematics written by N.P. Bali and Manish Goyal, and one more is there Higher Engineering Mathematics written by V.V. Ramana. These are having basic problems, so you can solve those problems to get the clarity about these problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.